Hi, geometry students. So last week we had a land surveyor that came in and showed us a couple of neat things, and I wanted to go over the problems, some of the problems that he had on the board, and also introduce a new concept to you as well. So we'll be using law of sines and we'll be using SOHCAHTOA. So this is the first problem he had on the board. So it was you're a land surveyor and have to do a survey for a new cell tower. What's the height of the new cell tower? So maybe they need to know that, for some reason, that's what he was saying. So let's say he sets up his little tripod here. Let's say that tripod's 3 feet in height. And when he measures it up to the top, he measures it as 40 degrees, okay, up to the top of that cell tower. Let's say he also makes sure he knows this distance here. He's 100 feet away from the cell tower, from the base of the cell tower. And so our goal is to figure out the height. So we're going to do that. I'm going to do it on a separate sheet of paper, but you should have this worksheet. So what we have to do is we have to set up a ratio. We have to use sine, cosine, or tangent. So we have to remember, we always have to remember to do, always write down SOHCAHTOA, right? You always want to remember to write that down. So sine stands for opposite and hypotenuse, cosine is adjacent and hypotenuse, and tangent's opposite and adjacent. So let's see what we have. So if you look at your angle, okay, you have the side across that you're looking for. So we have something across or opposite. So we have opposite, okay, and then it looks like we don't have the hypotenuse, so we're not going to deal with the sine or the cosine because they require the hypotenuse. This is the adjacent side, meaning the side next to the 40-degree angle. So apparently we have opposite and adjacent. So what is that? You could probably guess it already. Opposite and adjacent, that's tangent. So we're going to do, for number 1, we're going to do tan, and remember it was 40 degrees, so tan 40 equals, and then opposite, if you look at the diagram again, opposite side was height, and then the adjacent side was 100. So we do height over 100, okay? And so now we just put it in our calculator, okay? And before we do that, let's just solve for h and do one less step. So if I want to get h by itself, I have to multiply both sides by 100. So if I were to show that, I'm just showing that I'm multiplying both sides by 100, and these 100s end up canceling because one's being multiplied, one's being divided, so those are inverse operations. So really, this is what I want to put in my calculator, 100 tan 40. So that's what I'm going to do. So 100 tan 40. Always make sure you're in degrees if that's what you're doing. And it says here I'm in degrees. So 83.9 is what we get. So 83.9. And that's, depending on what we're dealing with, we had feet here, okay? So this is 83.9 feet, but we're not done yet because if you remember, the height of our little pole here, the height of the surveyor thing is 3 feet. So I just found h, and that's from this point here up to the top. But I'm not including these 3 feet here from, this land surveyor thing. So I need to add that back. So if we add 3 more feet, then we'll get 86.9 feet. So that's the answer for number 1, 86.9 feet. All right, number 2. Now, we have a slightly different problem. He also put this one on the board. There's an oil rig offshore. So you're, looking off from the beach here. The little umbrellas or something. So we're looking off from the beach, and we're surveying to find the distance from the beach. Okay, the distance of the oil rig from the beach. So we have to mark 2 points. He said that basically you would have, you'd measure, let's say, your degrees from this angle, or from this spot, let's say, and then you would go to another spot and mark that off, and then you would measure again, looking the other direction, okay? So let's say you were the surveyor and you were at this spot, and you looked out to the oil rig and measured it to be 80 degrees from this point, okay, or from this line, say 80 degrees. All right, and then you came over here, and then when you were looking up this way, you measured it to be 77. So you went 50 feet, basically, in between the two. So let's just set this up then. Right now, if you think about it, I can't use law of sines just yet. Remember, I have to have a side, and I have to have the angle opposite that side. We don't have that yet, so what do? Well, we know that there are 180 degrees in a triangle, so to find that other angle over here, we're going to do 180 minus 80 minus 77, because that's what we had, 80 and 77. So we're just subtracting that. Okay, so then just come over here and 180, we know 180 minus, we can actually do this in our head, but 180 minus 80 is 100. And then if you subtract 77 more, you should get 23. So indeed, we get 23 degrees here. And again, this is just hypothetical, but so 23 degrees, let's say, is our angle. So now, again, we know that this is 23 degrees. And now we have to set up some different ratios to find x and y, to find different ones here. So again, I'm just going to redraw this. So 23, 80, 77, and 50. All right, so now I'm ready to do the law of sines, because I can do the sine, remember, of the angle, which is 23, and then you always need the side opposite that, so over 50, okay? And then that equals, and now we can find another one. So remember, x was up here, I believe, y was down here. Let's make sure that's right. Yep, okay. Making sure that's right. So let's solve for x first. So we're going to have to use the angle that's across from that, which is 77. So we have to do sine 77 over x. That's what we're looking for. We can set up the other one as well. I'll just do it over here. So we can use the same one, sine of 23 over 50, being as we already used that before. Sine of 23 over 50 equals, and then for this one, we would do sine of 80 over y. And we just have to solve these two things. So remember, we're going to cross multiply. Okay, so if I cross multiply, I'm going to multiply 50 times sine of 77. So 50 sine 77 equals, and then if you go this way, it's x times 23, or sine 23. X sine 23. And then remember, just to get x by itself, we want to divide both sides by what's next to the x that's being multiplied. So sine of 23. And so now, when I multiply, or I'm going to do all this basically together on here, I'm going to do 50 sine 77 divided by sine 23. And I get 124 point, we can round it, 124.7. So x equals 124.7 feet. So if this was feet, again, this would be feet. So we can kind of decide how we want to do that. We could also do meters if we wanted to. So, all right. So then on this one, same idea. Multiply, cross multiply, right? So we're going to do 50 sine 80. So multiplying these two together, 50 sine 80 equals, and then I'm going to do y times sine 33. or 23, sorry. And then what I do is, again, to get y by itself, I just have to divide both sides by sine 23. So sine 23. And then on the calculator, I'm just going to do that. So 50, here we go again. 50 sine 80. Okay, divided by, and then what was it, sine 23? And we get 126. So they're pretty close to each other. So 126. The final thing we're going to do is we're going to do a couple measurements with boxes. And remember, he was talking about you know, finding the diagonal of a 3D object, finding the diagonal of a box. So let's say you're going to have a shoebox that I'm going to give you, okay? So I'll show you how to do one of these, and you're going to have to repeat it. Okay? Repeat it for the room. Try the room, and we're going to do a couple of different shoe boxes. So let's just say, like I said, that I have a shoebox that is, let's say let me think. Let's say 5 or 6 inches high. Let's do that. 6 inches high, and maybe 18 inches long. Okay, and then let's say for the width, let's just say 10. So we'll do inches. Okay. So let's say that's our dimension. You know, we've got, like I said, we can call it length, width, and height if we want. So length and width. So we'll say length is 10, width is 18, and height is 6. Let's just say that. So remember, that's helpful to find volume. But what if you want to know, for some reason, let's say you want to know the diagonal for shipping purposes. Let's say you want to know the diagonal from here to here. From one corner of the box on the top down to the bottom quarter opposite that. So what you're going to have to do is that formula that he showed us last time. It's really like the Pythagorean Theorem, except now you have an extra variable. So normally it would be a squared plus b squared equals c squared, right? But now we have 3 dimensions here. So now it's that. Okay, a squared plus b squared plus c squared equals d squared. So now all we have to do is fill these in to find the diagonal. So just fill in all these different variables. So basically, like if you were to rewrite this using our variables, it would be length squared plus width squared plus height squared equals the diagonal squared. Okay, so we can fill those in. So 10 squared plus 18 squared plus 6 squared ends up being, so let's just check that out, 10 squared plus 18 squared plus 6 squared, 460. And you got to remember that's equal to d squared. So now we have to take the square root of that number. And we get 21.4. So the diagonal is 21.4 inches. So again, remember, these were all in inches for the shoebox. So what you're going to do is measure the length and width and height of your shoebox, just a couple of different ones. And then you're also going to try and see if you can find the diagonal of the room. So I'll give you guys a measuring, just a measuring thing for that. And then, yeah, just make sure you show all your work.